This is Tolbergia Antarctica. This is what we affectionately refer to as the ghost collembola. And we call it the ghost collembola because it's white, like a ghost. But because we had not found it after looking for it for years and years and years, we started to wonder if it was even real, if it really existed. It had been described by a scientist that went to Antarctica in the early 1960s, near the Shackleton Glacier region. We just never saw it. And finally, we're like, let's go to the exact place where this scientist described it the first time and see if it's there. The white strip that you see there, that is the Shackleton Glacier. When you see this landscape, right, your natural inclination is like, this is like a gravel pit. There's not gonna be anything alive here. So I moved some rocks out of the way to take a soil sample, and on the bottom of the rock, I could see this collembola crawling around. And that's its natural habitat. It lives on the bottoms of these rocks, crawling around, and you can see that that rock's got some moisture on it, so the conditions are just right for that animal to live there. This particular species, and in fact all of the species that are in this paper, are endemic to Antarctica, and they have lived there for millions of years. That little ghost collembola, that's only found on 3 little spots in Antarctica. So as a species, or at least as an evolutionary lineage, it's persisted for over 30 ice ages. Collembola, they're described as primitive insects. So this lineage diverged from the lineage that became all of the rest of the insects. And most springtails, we call them springtails because back here they have a furcula, a spring, that they can use to hop around like a kangaroo. But in Antarctica, these animals have lost that ability to do that. So you've got these 3 little legs that they crawl around with, and they're hauling this great big sleeping bag of a body behind them, grazing on organic matter in the soil, and there's not much of it there, right? So slim pickings most places this guy goes, which is why they're restricted to these areas that have, that are just like Goldilocks environments for them. Like not too cold, not too dry, not too harsh, not too, like it's gotta be just right. They move maybe this much in their lifetime, and they don't have wings to fly away with. They don't get up on top of the soil and crawl away. They don't blow away by the wind. And so really the only way that they can migrate, can move long distances, is in open water. When we look at the evolution of these organisms, we can see that the timing and pattern of their population structure corroborates what we know about the pattern of the West Antarctic ice sheet when it's open ocean and when it's not. This organism's evolutionary history is telling us something really cool about ice sheet dynamics in Antarctica that are highly relevant to sea level rise and how our planet's responding to climate-driven changes. And then ultimately it can tell us something about the impacts that that's going to have on our planet into the future.